our solutions for quiz 7 for Math 243. What's going on here is we are doing hypothesis testing, specifically z-testing. So suppose I've extracted spray from rhinoceros horns, okay, that I claim affects a sprinter's speed. Affects will be huge here. Maybe I'll even underline it. Affects a sprinter's speed. You know that on average a sprinter can run 34 miles per hour, okay? So this is all sprinters. We're talking about mu here, but we want to use the symbol mu naught so that we can say mu for something else. With a standard deviation of 8. Again, this is not a standard deviation of our sample. It's for all sprinters, so this would be sigma. But now we start talking about our sample. We have a random sample of 144 sprinters. So that's going to be n, the number of observations in our sample. And for those n, we got x bar is 35.2. So x bar, our sample average is 35.2. And we want 95% certainty, so alpha is equal to 0.05. All right, and I think that's everything we need. I don't know if I'm going to have you write out mu, but I'm going to write it so that we have it as reference. What mu is the population average speed maybe of all sprinters. So I'm not just talking about my sample here, I'm talking about all sprinters. But not all sprinters, period. All sprinters using my spray. Using RH spray, rhinoceros horn spray. So that's what mu is. State the null and alternative hypothesis. Sure, this is classical hypothesis testing here. My null hypothesis is that mu, this thing that I just talked about, is the same as mu naught. It's just equal to 34. My alternative hypothesis, be careful here, it's that mu, I claim that it affects a sprinter's speed. So it would be that mu does not equal 34. I'm not saying this thing makes people faster or slower. I'm saying that it affects. So what I have here is a two-tailed test. Mu equals 34 is my null hypothesis. Mu does not equal 34 is my alternative hypothesis. State the shape, center, and spread of this thing. Sure. Shape, center, spread. The shape is approximately normal. That is some horrible handwriting. Let's try that again. S-P-R-E-A-D. And yeah, I guess that says center up there. Center. Just making it worse. Okay, the shape is approximately normal, because it always is. But we'll want to justify why. And the reason why is because our value for n is greater than or equal to 30. I think there are 144 sprinters. Yeah, n is 144. That's certainly greater than or equal to 30. So therefore, using the central limit theorem, we have that the shape is approximately normal. Down here, when I draw my picture, I want to draw something approximately normal. Yeah, good enough. I guess that's approximately normal. Center, we use our value for mu naught, which in this case was equal to 34. The reason we do that is because we assume our null hypothesis is true, that mu is equal to 34. So there's our center right there. And our spread, it's the standard deviation of the sampling distribution, which is sigma over the square root of n, which in this case sigma was given to us as 8, and n was 144. So that's 8/12, which is 2/3. Yeah, n was 144. So I don't know, 2/3, 0.67, something like that. Yeah, that's true. Okay, shape, center, spread. Sketch a distribution under the assumption that the null hypothesis is correct. Make sure to include z-scores for the rejection regions. Okay, so what we're saying here is in the center, put 34 like you always do. But we're going to have x values and we're going to have z values, so I'm going to put a 0 down here. And then what I want are rejection regions. In this case, I have two regions because this is a two-tailed test, and the total area of my rejection region should be 5%. So what I'm saying is I have a region over here and a region over here, and the total area of these shaded regions is 5%. In other words, each of these are 2.5%. Guess that's good enough. So what I'm saying is this is 2.5%, 0.025, and this is 2.5%, 0.025. So what we have to do is figure out what values correspond, what are my critical values here, what values correspond with my rejection regions. And you can figure that out in a few different ways. Because we have them on both sides, you could use z interval to figure out what those are. I think an easier way to do it, since we want the z values, is just to use inverse norm. So you hit distribution, inverse norm, then to figure out, I don't know, this value, we can say, well, if there's 2.5% above that value, there's 97.5 below that value. And since I want the z value, I'll put in 0 and 1. And maybe you have these memorized. This z value is 1.96. And if this z value is 1.96, this one's negative 1.96. And we don't have to figure out what the corresponding x values are. You can if you want. All you'd have to do is change this 0 and 1 into 34 and 0.67. But I don't really care. I'll leave it just like that. So sketch a distribution. Make sure to include the z-scores for the rejection regions. Guess I've done that. And then it says calculate your test statistic and draw your conclusion. All right, the way you do that is you go to stat, cal tests, z-test. We have statistics. We know that mu naught is equal to 34. We know that sigma is equal to 8. Be careful, it's sigma, not sigma sub x bar. X bar, how fast were this? 35.2 in our sample. And n was equal to 144, the number of sprinters we looked at. And this is a two-tailed test here, that mu does not equal mu naught. So now if I go down to calculate here, I'll get my z-score is 1.8. In other words, this value of 35.2, I'll put it over here, only has a z-score of 1.8. My test statistic's over here in my picture. My test statistic is not in my rejection regions. So I'll say, because my test statistic is not in the rejection region, I guess there's two of them, so you could say rejection regions, is not in the rejection region, there is not sufficient evidence to reject the null hypothesis. And that's all. We're not saying that the null hypothesis is right, we're just saying there's not enough evidence to conclude that it's wrong, because our test statistic is 1.8 was not in the rejection region. Now it says do it all over again using the p-value method. The good news is that'll go much quicker, because we don't need to do steps A and B, they're already done. And then for step C, it just says draw your distribution, showing the test statistic and the p-value. Okay, we have all those already. We know that the middle was, what was it, 34? And that has a z-value of 0. But our test statistic, which corresponded with a speed of 35.2, had a z-score of 1.8. So that's all information that I had on my picture up here. The one thing that I'm going to change is I'm not going to have a rejection region. I'm instead going to draw my p-value. Be careful here. It would be really tempting to just think this thing is your p-value, but it's not, because this is a two-tailed test. So because this is a two-tailed test, we need another point out here for negative 1.8. And we need the area below the negative 1.8. And if I had drawn these a little bit more carefully, maybe I can do something like this. Should be symmetric is what I'm trying to get at here. And the total p-value, the area for both of these guys, is equal to 0.07. 0.072 maybe. So this total area is 0.072. And then under the p-value method, we'd say because our p-value of 0.072 is greater than alpha. Alpha was only 0.05. Because our p-value is greater than alpha, there is not sufficient evidence, blah, blah, blah. There is not sufficient evidence to reject the null hypothesis. And that's all. That's all you say. You don't say that the null hypothesis is correct. You just say there's not enough evidence to conclude that it's wrong. That's it. That's the end of this problem, the end of this quiz.